Before you can analyze warehouse data, you have to speak its language. Everything in this series comes down to sizing real operations from real numbers, and that only works if we agree on what the words mean. So this one is the vocabulary. 18 terms in 5 families. Let's go. First, the building blocks, the things we count, and the units we count them in. Start with the SKU, a stock keeping unit. It's one uniquely identified product. A blue medium shirt and a blue large shirt are 2 different SKUs. Every SKU is a row in your master data, and the number of them drives how much storage you need. An order is one customer request to fulfill, one shipment's worth of demand. Orders per day is the headline number. It sets the throughput the whole pick operation has to keep up with. An order line is one SKU on one order with a quantity. 3 different products on an order means 3 order lines. This matters more than almost anything else because order lines are pick effort, and lines per order tells you whether you're a single-line e-commerce shop or a multi-line wholesaler. Pieces, or units, are the individual items, the quantity sitting on each order line. How many pieces per line decides whether you're picking single items, whole cases, or full pallets. A transport unit, a TU, is a load carrier that moves as one handling unit. A pallet, a case, a tote, a container. It matters because storage and transport are sized in transport units, not in loose pieces. Unit of measurement, UOM, is the unit a quantity is written in, each, case, layer, pallet. It's easy to overlook and dangerous to get wrong. Quantity 12 means nothing until you know whether it's 12 eaches or 12 pallets. Equivalent transport units put everything on one footing. You convert mixed quantities into a common carrier count, say, equivalent pallets. 48 cases at 24 to a pallet is 2 equivalent pallets. Now you can add and compare flows that were measured in different units. Next, the 2 kinds of data every analysis starts from. Master data is the static reference data. It describes the things. Your SKUs and their dimensions, weights, cases per pallet, storage class. Remember this, the quality of your master data caps the quality of every calculation you'll ever make on top of it. Order data is the opposite. It's transactional, the record of what actually happened. Orders, lines, quantities, dates, over a period. This is where real demand and seasonality live. You size a design against real order history, never against the catalog. Now the statistics, how we turn thousands of rows into a handful of honest numbers. The average, or mean, is just the sum divided by the count. It's a quick sense of the middle, but be careful, it's easily distorted. One giant 5,000 line order pulls the average lines per order up and can quietly mislead your whole design. The median is the middle value when you line everything up in order, half below, half above. Because outliers don't drag it around, the median usually describes the typical order far better than the average does. Standard deviation measures spread, how far the values sit from the average, and spread is really variability. A low deviation means a steady, predictable workload. A high one means you have to design for the peaks, not the average. A percentile is the value below which a given share of your data falls. The 95th percentile is the value that 95% of observations sit at or under. This is the sizing tool. You build capacity to a percentile, not the average and not the single worst day. Design for the 95th percentile day and you cope with almost everything without overbuilding. Then classification, sorting the catalog by how hard each item actually works. A, B, C movers rank your SKUs by activity. A are the fast movers, C is the slow long tail, and usually 80% of the picks come from 20% of the items. But here's what people get wrong. The fast movers are your core business. They're already efficient, whether they sit in manual storage or automated mass storage. It's the medium and slow movers that hold most of your SKUs and most of your storage cost, so that's usually where automation pays back the most. And finally, the 4 ways we pick, from whole pallets down to single pieces. A full pallet pick is exactly that, a complete, unbroken pallet moved as one unit. It's the cheapest handling there is per piece, and it drives your bulk storage and pallet equipment rather than pick faces. A partial pallet pick takes part of a pallet, often whole layers, but not the full thing. It sits between pallet and case work, and it shapes how you design your layer pick zones. Case pick is picking whole cases from a pallet or a flow location, not the full pallet and not loose pieces. It's the everyday workload of a lot of wholesale operations, and it sizes your case pick faces, your flow rack, and your conveyor. And piece pick, picking individual items out of an opened case. It's the most labor-intensive pick there is per unit, it dominates e-commerce, and it makes the strongest case for automation. Goods to person, put walls, A-frames. That's the vocabulary. None of these terms are complicated on their own, but each one changes a number in the design. And if two people mean different things by order line or transport unit, the whole analysis drifts. Get the language right, and the analysis takes care of itself. See you in the next one.